Hello students, a very good afternoon to all of you. In the last class we were studying about electric field and we also did some questions related to it. So today we are going to find how to measure electric field due to different charge configurations. Okay, so let's start. If we have to find electric field due to a point charge, we can say that let's say this is a point charge placed here. From this point charge, let's say this is point charge Q. From this point charge I am taking a point P at a distance R. Okay. Now at this point P, if I have to tell what will be the electric field due to this positive plus Q positive charge, then the direction of electric field can be given by this, that is away from the positive charge. So that's why we are taking electric field at point P as EP vector, and what I am supposed to write, EP vector is equals to force experienced by a positive test charge placed at point P. Let's say the positive test charge is plus Q naught. Okay, plus Q naught, very small positive test charge. Now in that case we can say electric field at point P due to plus Q will be given by force experienced at point P, force vector divided by Q naught. So in that case we already know by Coulomb's law that force between two charged particles can be given by K Q1 Q2, that means K Q naught divided by distance square R square upon Q naught. Force, and this is vector, force vector. So in that case we can write the vector or the direction representing the line joining these two charges or the point P from the charge plus Q is given by R vector and the direction is given by R cap. So we can use anything which we require, like Q naught by R square is magnitude, and if we are supposed to write just the vector we can say R cap. So Q naught and Q naught will cancel each other and we will get KQ by R square R cap. So this will be the direction of electric field at point P due to this plus Q positive charge, that is point charge. Okay. So according to the definition which we did or which we knew since the last class, the same we are using and we are writing electric field due to this point charge at point P. Let's proceed. Now if we have to find electric field strength due to a uniformly charged rod, what we are supposed to do? Now in this we are taking case 1, that is when the point is present at an axial place or on the axis. How? Let's see. Suppose this is our positively charged rod. So this is my positively charged rod. In this, which point we are considering? This is the axis where the rod is placed. So on this axis I am taking a point P. Let's say this is a point P. I already know how to find electric field at this point P due to a point charge if I consider any point charge on this particular rod. So in that case what we can do? We can take an elemental charge, let's say this charge is dq. Okay, let the length of the rod be capital L. Okay, let's say the distance P is, the distance of point P from the end of the rod is small r. Now if I have to find electric field at point P due to the whole rod, firstly I am finding electric field due to this particular element at point P. Okay, so in that case what we are supposed to write? Electric field at point P DEP is equals to, because we are writing for, because of this small element, so we can say K dq divided by distance square. What is the distance? Let's say this element I am taking at a distance x from this end, and the length of this element is dx. Okay, so we can write k dq divided by distance square. What is the distance between this point charge and point P? The distance, total distance will be r plus x. Okay, so in that case we can say r plus x whole square. So kq, k into charge by r plus x whole square. So in that case we can say, what will be the value of charge dq of this element? Charge dq of this element can be defined as, what is the total charge on this rod? Let's say the total charge is plus capital Q. In that case we can say charge on this element will be given by total charge capital Q divided by the length of the rod into length of the element. What is the length of the element? Dx. So that's how we will write dq. If this is the value of dq, I am putting this value in that expression which we are getting for electric field. So in that case we can say k into capital Q by L into r plus x whole square dx. No problem. Now this was electric field due to a point charge or a small element which we have taken on the rod, but we have to consider electric field due to the whole rod at point P. In that case we can write net electric field EP at point P will be given by integration of this dEP. From where to where? From value of x 0 to capital L. So in that case we can say 0 to capital L will be the limits kq divided by L dx upon r plus x whole square, and limits will be 0 to capital L. So in this case we can say electric field at point P is equals to kq divided by L. Now tell me, do you know how to write value of integration of dx upon x square? It is minus 1 upon x, right? Similarly, since we are writing a linear expression only, dx upon r plus x whole square, the integration will be minus 1 upon r plus x, nothing different. So that's why the integration of dx upon r plus x whole square, I am replacing that by minus 1 upon r plus x. So this gives me minus 1 upon r plus x, lower limit is 0, upper limit is L. So electric field at point P is equals to kq by L minus 1 upon r plus L minus plus 1 upon r. Okay, so this gives me electric field at point P. Electric field at point P will be given by kq by L r plus L minus r divided by r into r plus L. So in that case r and r cancel, L and L cancel, and this will give me electric field at point P is equals to kq divided by r into r plus L. Okay, so in that case this will be the answer. Electric field due to this charged rod at point P will be given by kq upon r into r plus L. If you are finding it tough to see the answer, I am highlighting it. Okay, next. So till now we have found electric field due to a charged rod at an axial point of the rod. What if we have to find at a point which is present at equatorial axis? So in that case, let's make a rod first. So this is a charged rod, positive, positive everywhere. Okay, and this is the equatorial axis, that is the perpendicular bisector of the length of this rod. So in that case, if the total length of the rod is L, I can directly write that the length here, this half will be L by 2 and this half will be L by 2, because I am already telling that the total length of the rod is L and this is perpendicular bisector, or you can say equatorial axis for this rod. Now I am taking a point P, let's say here we are taking a point P. Now let's consider one element here. Let's say this is one element. The length of the element, let's say it is x distance away from the center, and the length of the element is given by dx, such that the total charge on this element is dq. Now what we are supposed to say, due to this point charge, electric field at point P will be given by this vector. Let's say dE is the electric field due to this point charge or the elemental charge which we have taken on the rod at point P. Let's consider this angle as theta. Now if this angle is theta, we can easily mention that this vertically opposite angle will also be equals to theta. In this case, this will be the direction in which we can write the component dE sin theta, and in this direction the component which will come is dE cos theta. So one thing we can be sure, that if I am going to take many elements on this rod, like small elements which we are taking on this rod, then what will happen? In that case, this side of the elements will give electric field, horizontal electric field in left direction, and this side of the elements will give horizontal electric field in right direction. So this dE sin theta is going to be cancelled. So I don't have to worry about this component of electric field which is present due to this element, because overall if I integrate for the whole rod, this dE sin theta is going to be cancelled due to the symmetry, because this side will have horizontal electric field in left direction and this side will have horizontal electric field in right direction. Okay, so now what is left? Only dE cos theta will be left. So I will integrate dE cos theta for the whole rod and then we will proceed. So in that case, what we can do, I can write expression of dE cos theta equals to, first of all, what is value of dE? Value of dE is given by k dq divided by distance square. What is the distance? If this is x and this is dx, and let's say this is a small r, distance of point P on the equatorial axis is small r. So in that case, this distance can be written as r square plus x square under root of r square plus x square. So in that case we can say dE will be given by k dq divided by distance under root of r square plus x square, and this dE cos theta will be k dq divided by under root r square plus x square into cos theta. Cos theta is how much? Base by hypotenuse. What is base? R. What is hypotenuse? Under root r square plus x square. So now see here, electric field which we have taken is k dq by r square. So obviously square must come here and square must come here. Okay, don't miss this square. Electric field due to this element dE at point P, magnitude is given by k dq divided by distance square. So I have applied square here as well and here as well. So now in that case, what we can write? dE cos theta will actually come equals to k r dq divided by r square plus x square raised to power 3 by 2. How we can write value of dq of this charge? See, the value of total charge on this rod is capital Q. Okay, and let's say the length of this element is dx, which we have already specified. So in that case we can say that total charge Q divided by length of the rod into length of the element, that is dx. Similar to what we have used in the previous example as well, in the previous case as well. So now in this case what we can see? We can see that dq is equals to q by l dx. I am just putting the value here, k r by r square plus x square raised to power 3 by 2, and instead of dq I am putting the value from here. So if I am putting the value from here, q upon L dx. Okay. So if you ask me what will be the net electric field due to this whole rod, I will integrate this expression. So in that case, E net will be equals to integration of dE cos theta. Integration of dE cos theta. So that's what I am writing here. K Q R divided by L dx upon r square plus x square raised to power 3 by 2. K Q R divided by L into r square plus x square raised to power 3 by 2. Integration. From where to where? From value of x. See, from here we have taken plus L by 2, right? So from plus L by 2 to minus L by 2, or from minus L by 2 to plus L by 2. No problem. So this integral we will have to find. How we are supposed to find the value of this integral? The value of this integral we have to find separately. Let's see. So the integration is dx upon r square plus x square raised to power 3 by 2. This we have to integrate. Okay. Okay. So that's what we are getting from here. Put x is equals to r tan theta. So in that case, this expression r square plus x square raised to power 3 by 2 will become how much? R square into 1 plus tan square theta, that is r square sec square theta raised to power 3 by 2. So this will become r cube sec cube theta. Okay, r cube sec cube theta. And if x is r tan theta, I can say dx will be given by r sec square theta d theta. Okay, so now this expression I am writing r sec square theta d theta divided by r cube sec cube theta. Integration. So this will become 1 by r square, and this sec square theta will also cancel this sec theta, and this will become sec theta. So it will be actually cos theta d theta. The value of this will be integration of cos theta with respect to theta, and 1 by r square will be outside. So from here we can see that 1 by r square into integration of cos theta is given by how much? Integration of cos theta is actually given by sin theta, right? Integration of cos theta is sin theta, because differentiation of sin theta is cos theta. So now using this value there, I can write, see, if I already know what is cos theta for this triangle, I can mention sin theta as well. Sin theta for this triangle will be equals to how much? Sin theta is equals to perpendicular, that is x, divided by hypotenuse. So x divided by r square plus under root of r square plus x square. So this is our value of sin theta. Now the value of this integral is coming how much? 1 upon r square sin theta. So we will use it. E net will be given by k capital Q R by L into, in place of integral I am replacing that integral by the value 1 upon r square into value of sin theta. So that is 1 upon r square, and value of sin theta is x upon under root r square plus x square. So this is what we are getting, and limits are minus L by 2 to plus L by 2. Same. So 1 upon r square and r will get cancelled, and 1 r will come here. So from here E net is equals to k q by r L, and from here we can say L by 2 divided by r square plus L square by 4, r square plus L square by 4 under root minus plus L by 2 divided by r square plus L square by 4. That's it. So in this expression which we are getting here, the the answer will be coming how much? Let's change the color to avoid confusion. So which color will you like? I think you will like violet color or dark blue color. So from here, this expression I am writing the answer directly. How? See, I will cancel L from here directly. 1, 1. Okay. And 1 by 2 of this, 1 by 2 of this, I can write directly the answer. How much it is? It will be equals to E net equal to KQ divided by R into R square plus L square by 4 raised to power 1 by 2. Okay. So that will be our answer. So answer for electric field at an equatorial point on rod will be given by KQ upon R into R square plus L square by 4 raised to R 1 by 2 if the point is located at a distance R from the rod. Okay. So let's proceed further. If this answer is not visible to you, let me highlight. So this is the answer for this particular case. Let's proceed. Electric field strength due to a uniformly charged long thread. What we are supposed to write in this? How to find this? Electric field strength due to a uniformly charged long thread. Long thread means infinite thread because they are not specifying the length. So long thread for us will actually become infinite thread. So let's take a charge, positively charged thread like this, where the length is not finite. So this will be like this. All over the rod positive charge is placed like this. Okay. So now what we are supposed to write in this? See, there is a point P. At this point P, I wish to calculate electric field due to this long thread. In that case, what I will do? See, again, the same phenomena, the same philosophy we have to follow. What is that? Take one elemental charge. Let's consider the elemental charge is present at a distance y from here and the length of this elemental charge is dy. Okay. So in that case, what will be the magnitude of electric field at point P? The magnitude of electric field at point P will be given by, let's say this is dE, okay, and this is angle theta. Now what we can say from here, value of dE electric field due to the component which I have taken can be written as, but I also should know the charge dq which this element is having. How I am supposed to define that? Let's take the charge per unit length, that is lambda coulomb per meter, as charge per unit length for this particular long thread. So in that case, what we can do, dq can be written by charge per unit length lambda into length, that is dy. So that's what I am supposed to, or I am going to write when I have to write dq charge anywhere in the expression. So now if this angle is theta, this angle is also theta, and it is a long thread, so we can say there will be two components, d cos theta and d sin theta, but the other half or the bottom half of the length will give d sin theta in this direction or opposite direction. So in that case, we don't have to worry about this component of electric field, and we will integrate this d cos theta component for the whole length. In that case, we will get electric field due to this linearly charged thread, long thread, okay, by integrating the value of d cos theta. But this component d sin theta will get cancelled if I integrate and find electric field for the whole long thread. That's why we don't have to worry about this component. So for d cos theta, what I will do, firstly let's write the value of dE. So I am writing k dq divided by distance square. If this is y and this is r, we can write this distance is given by r square plus y square under root. So kq by distance square, that is r square plus y square, that will be dE. What will be value of cos theta? Value of cos theta will be base, that is r by hypotenuse, that is under root of r square plus y square. So in that case what we can say, dE cos theta integration is equals to k dq. Instead of dq I am writing the value of dq directly. What is that? Instead of dq I am writing lambda dy. So k lambda dy, that is dq, divided by r square plus y square into cos theta, that is r upon r square plus y square under root. So in this case we can write dE cos theta is equals to, integral of dE cos theta is equals to k lambda r upon r square plus y square raised to power 3 by 2 into dy, and this integration we have to have. Okay, from where to where? From minus infinity to plus infinity. Why? Because we are taking the length y. If we are taking the length y, we already know that this angle O, if we are taking y as the variable, it will be minus infinity to plus infinity, but if we are taking angle as the variable, it will be minus pi by 2 to plus pi by 2, right? Let's focus how to solve this integral. Okay, now we have already solved this integral of dy by r square plus y square raised to power 3 by 2. We already know how to, what's the answer we were getting for this? Let me remind you. So dx upon r square plus x square raised to power 3 by 2 integral, we got the answer as sin theta upon r square, or you can say x upon under root of r square plus x square into r square. So in that case what we will say? We can say that this can be expressed by k lambda r into k lambda r into integration of dy upon r square plus y square raised to power 3 by 2. So instead of that I am directly writing the value. See, focus here. In case you get confused, here we have solved this integral before. We have already solved this integral before and the result was coming sin theta upon r square. Okay, what was the result coming? Sin theta upon r square. So we will write sin theta accordingly. So k lambda r sin theta divided by r square. So that's what we will write, and the limits will be from where to where? Minus pi by 2 to plus pi by 2. Because let's say this is angle theta. If we are increasing the length, increasing, this theta will go to 90 degree, right? If we are increasing the length from here, again this theta will go to 90 degree till infinity. So in that case we can say k lambda by r sin pi by 2 plus sin pi by 2. Okay, because we have already done a similar calculation of this integral in the previous case, I have not done it again. Okay, so from here the answer which will be coming is 2k lambda by r. That will be electric field at point P due to the long thread. So that's our answer. I hope all of you understood how we have to do this particular case, or how we have to find electric field due to the long thread at a point P placed r distance away from the thread. Let's highlight so that it is clearly visible to you. Don't forget, because this will be frequently used directly in the formulas which we are going to use in the questions which we solve. Okay, so you have to directly remember 2k lambda by r for many of the cases, most of the situations. Let's see further. So now electric field strength due to a uniformly charged long thread, that is already finished. Electric field strength due to a uniformly charged rod at a general point in its surroundings. Okay, so that we will continue in the next class. till today. Whatever we have covered till today, please revise it and then attend the next class. Okay. So in that case, suppose if we have to solve this integral, okay. We have a lot of time now. We can continue from here. So long thread is done. Electric field strength due to uniformly charged rod at a general point in its surroundings. We have an ample amount of time. We can continue from here. Not a problem. So from here, what we can say? Electric field strength due to a uniformly charged rod will be given by, say, let's take a rod. Okay, I am not taking infinite rod this time. Okay, I am taking a finite length of the rod. So this is a positively charged rod given to me. Let's say the charge per unit length is lambda, coulomb per meter. So in that case, let's take a random point P where we are able to find electric field due to this. Let's say this is point P. So from here we can say, if this is angle alpha and this is angle beta, okay. So let's take one element either this side or this side. I am taking this side. So let's say this element is having charge dq from this point which we have taken. The distance of this element, let it be y, and the length of this element be dy. Okay. In that case, if we have to find electric field due to the whole rod, firstly we will find electric field due to this small element, and then we will be able to find electric field due to the whole rod at point P by integrating whatever we are getting due to the element. So now in that case, what we will do? Due to this element, we will write electric field at point P dE. Okay, dE is the electric field due to this small element at point P. Let's consider this angle as theta. And the length of this element is making angle d theta here. Let's consider. Now, if this is dE, then this angle, vertically opposite angle, will be given by theta, and this will be dE cos theta, and in this direction it will be dE sin theta. Okay. So this time the point is not placed at a symmetric position. We are having random position of this point such that the length of the rod is making angle alpha and beta when the point is placed like this. Okay. And we are having two components to integrate, that is dE sin theta and dE cos theta. dE cos theta will give us electric field in y direction, and integration of dE sin theta will give us electric field in horizontal direction or in x direction. Okay. So let's proceed one by one. Let's solve this one by one. Let's write electric field in x direction. So electric field in x direction will be given by dE sin theta, integration of dE sin theta. So what we can write in place of d, that will be actually, suppose if the point is placed at a distance r from the rod and this is y, then the distance of point P from the charge will be given by r square plus y square under root. Okay. So in that case we can say dE will be given by k dq divided by distance square. What is that? Under root of r square plus r y square was the distance, so we can write k dq divided by distance square into sin theta. What will be sin theta for this? Sin theta will be perpendicular, that is y by hypotenuse. So I am writing y divided by hypotenuse, that is r square plus y square raised to power 1 by 2. What will be the value of dq here? We have already told that the length of this elemental charge which we have considered here will be how much? Dy. So in that case we can say that charge per unit length will be lambda and the length of this element will be dy. So in that case we can write dq as lambda dy in this formula. So Ex will be equals to k lambda dy y upon r square plus y square raised to power 3 by 2 integration. Okay, so in that case Ex is equals to k lambda y dy upon r square plus y square raised to power 3 by 2 integration. From where to where? That we will apply later. After this integration is done, we will see about the limits. Now in that case, what we can write? If r square plus y square equals to t square, we can write 2y dy is equals to 2t dt. 2 and 2 cancel and y dy can be written as t dt. So in that case, we can change the limits. Or instead of that, it will be easier for us if we take the limits in terms of theta or in terms of angle. So in that case, instead of doing this, we can have another option. What is that? That will be easier for us. How? If we try to place y is equals to r tan theta, shall it be easy? Because r square plus y square raised to power 3 by 2 will become r square sec square theta raised to power 3 by 2. So this will be r cube theta, r cube sec cube theta, right? So from here we can use it directly in this equation. How much it is? K lambda, instead of y I am placing r tan theta. If y is r tan theta, what will be dy? Dy will be r sec square theta d theta. So that's what I am writing in place of dy, r sec square theta d theta, okay, divided by r square plus y square raised to power 3 by 2. R square plus y square raised to power 3 by 2, I have already written the value of that as r cube sec cube theta. So this is r cube sec cube theta, okay. So let's solve this integral further. In this we can directly cancel r from r cube, r and r as r square will cancel r cube and only one r will be remaining. Sec square theta will cancel this and only one sec theta will be remaining. So from here tan theta is sin theta by cos theta into sec theta. So that will again cancel and only one sin theta will be present here. K lambda by r, and in the integral it will be remaining only sin theta d theta integration. From where to where? Now if I am taking angle theta from here, I can say minus alpha to plus beta. Is it or not? I can say if I have to consider this theta angle, I can mention that this angle will be minus alpha to plus beta, so that I am able to cover the whole rod at once. So in this case, Malay Maskawade. Okay, sir, I have a doubt. Please ask Malay. So from sin theta d theta, from where we are getting the limits? Minus alpha to plus beta. So from here what we will get? K lambda by r sin beta plus sin alpha. Sin beta plus sin alpha. This will be our formula. For what? For Ex, for value of Ex. So this is how we are supposed to find electric field in horizontal direction due to this uniformly charged rod at a random point P in the given configuration. Okay. So from here what we can say? This is the expression we are getting for horizontal direction electric field no problem. What will be the case in case of y direction? See, one component we have integrated, that is d sin theta. What about the component d cos theta? So if I integrate d cos theta, that will actually give me electric field due to this whole rod in y direction. Okay, electric field due to this whole rod in y direction at this random point P. Okay, Malaya, if you Google search, you will find, no worries. Okay, let's proceed. So I have to find out electric field in y direction now. Ey is equals to integration of dE cos theta. Now value of dE I already know. How much was that? K dq by r square plus y square. That was value of dE actually. So we can write K dq. Instead of dq I will directly write the value of dq, that is lambda dy. So K lambda dy divided by how much? Distance square. Distance is r square plus y square whole square. So this is coming, instead of cos theta, what I can write? Cos theta was in this triangle. So cos theta is base by hypotenuse. This is base r and this is hypotenuse under root of r square plus y square. Okay. So in that case, we can say K lambda dy by r square plus y square into what we can write in place of cos theta? In place of cos theta, what will come? R divided by r square plus y square raised to power 1 by 2. Okay. Integration of this. From where to where? Limits I will apply once I will convert this expression in terms of angle. So from here we can get K lambda r and dy divided by r square plus y square raised to power 3 by 2, integral of this. And we already know how to write integration of this, we have already used. How? Let me remind you. Integration of K lambda r by r square plus y square, yes, this one, dx upon r square plus x square raised to power 3 by 2. This expression integral again is coming. So what I am telling you is, what I am suggesting you, at so many places we are using the same integral, value of same integral, dx upon r square plus x square raised to power 3 by 2 integral. So this is getting me sin theta by r square every time. Okay. So what I will suggest is, we can apply the same directly here and we will be able to write K lambda r 1 by r square sin theta from where to where? From where to where? From now see, after integration here we were getting what? We were getting sin theta, and after integration there what we will be getting? So from here what we are getting? K lambda r 1 by r square sin theta integral from where to where? From minus alpha to plus beta. Okay. So in this case what we will be getting? Okay. See, one elementary mistake which we have done here is, in this expression there is a change. What is that? There is integration of sin theta, right? So after integrating sin theta only we have to write the integral. So after integrating sin theta, what we can suggest here is K lambda by r, integration of sin theta will come minus cos theta, and this is minus alpha to plus beta. So the answer will change a bit by K lambda by r minus cos beta minus plus cos alpha. So this answer will be K lambda by r cos alpha minus cos beta. Okay. So this is a slight change in the value of horizontal direction electric field. I am also highlighting it in case required. So I am highlighting this expression. Okay. In Ex we are getting cos alpha minus cos beta. So that was the case. We have not integrated sin theta and we have directly written that. So that was an error in this. So this is the expression for Ex, and in the expression of Ey we are getting directly sin theta. So if we are getting directly sin theta, let's change it to the black. We are getting directly sin theta, we are getting the expression K lambda r by r square and instead of sine theta I can write sine beta minus minus plus sine alpha. So from here we can say k lambda by r sine alpha plus sine beta. Okay, so this will be the expression for Ey. So again I am writing both the expressions. We are getting Ex as k lambda by r cos alpha minus cos beta and we are getting the expression Ey as k lambda by r sin alpha plus sin beta. Okay, so this is the expression for Ex, this is the expression for Ey. I hope no confusion is there in case of finding electric field in horizontal direction or electric field in y direction due to a positively charged rod at a random point. Okay, okay Malay, I hope you understood if you are studying here. Next, electric field strength due to a charged ring. So electric field strength due to a charged ring, let's find out. Let's change the color to red. So let's make a ring. On this ring positive charge is distributed all over the surface, everywhere. So positive charge is distributed all over the ring. I am taking one point on the axis of the ring, that is point P here. If point P is present on the axis of the ring, what we can say? Let's take one element here. Okay, due to this elemental charge, I have to write electric field at point P. Let's match the point P with the element first. So due to this element, if I have to show electric field at point P, what will be the direction of electric field at point P? That is dE at point P. dE at point P due to that positive charge. Now in that case, what we will suggest? If we are taking another element from here, and I match the element like this, again it will give me dEP. So we have taken electric field due to both the elements same because of the symmetry. Okay, Malay, what problem you are having? Please ask. Which one? So in that case, what we can suggest here is, if this is angle theta, this will also be angle theta. Let's say this radius is r for us and this total charge on the surface of the ring will be q. So if I have to tell that this element is having some electric field here, let's say this element is having charge dq. Okay, so in that case the value of dEP or electric field due to the element will be given by k dq divided by distance square. What will be the distance? Let's say the point P is x distance away from the center on the axis and this radius is r. So in that case we can say this distance is r square plus x square raised to power 1 by 2. Okay, so r square plus x square raised to power 1 by 2 is a distance and I am squaring it. So this will give me r square plus x square. So value of electric field due to the elemental charge will be equals to k dq by r square plus x square. So in this case what we can write? I can write dEP cos theta into 2 will be the net electric field here, right? dE net. Due to both the elemental charges, net electric field will be dEP cos theta and dEP cos theta from the bottom. Okay, so dEP cos theta into 2 and here it will be dEP sin theta, and they will cancel each other. Okay, so in this case we can write dE net is equals to dEP cos theta into 2 and integration of dE net will give us E net due to the whole charge on the ring, and this will be integration of dEP cos theta and 2 is outside. Now tell me, if I put the value here, what will come? K dq by r square plus x square. 2 is still there. Instead of cos theta, what we can put? Instead of cos theta, what will come? Cos theta will be actually base by hypotenuse. So this is base x, hypotenuse will be r square plus x square raised to power 1 by 2. So we can write 2 into k. So this will be actually value of cos theta. What to write? So value of cos theta we will be able to write equals to x divided by r square plus x square raised to power 1 by 2. So this is value of cos theta, and we have to integrate it from where to where? See, one thing we have to focus here. We have already considered two elements, one at the top, one at the bottom. So that means when we are integrating for two elements at once, we are not integrating from charge 0 to plus q. We are actually taking charge 0 to q by 2, because for half the charge will be q by 2, for another half of the ring the charge will be q by 2. So in that case we have to consider that this integration is actually from 0 to plus q by 2. Why? Because we have already considered two elements at once, one from the top and one from the bottom. So from here we can see 2k x divided by r square plus x square raised to power 3 by 2. Then integration of dq will be equals to from 0 to plus q by 2. I have put the limits. So from here we are getting 2kx divided by r square plus x square raised to power 3 by 2 into capital Q by 2. So from here 2 and 2 we can cancel, and this will give us kqx divided by r square plus x square raised to power 3 by 2. So this will be the value in case of electric field, net electric field due to the ring. Okay, I am making it in column. This is our answer. Let's highlight if you are not able to visualize it properly. This will be the value. If you memorize it directly, it will be helpful for you at many questions where we can use it directly. kqx by r square plus x square raised to power 3 by 2. No problem. I hope all of you understood how we are getting this expression, and Malay asked me to explain the previous one once. Okay, I will explain for him the previous one once again. Malay, actually I have done this thing. I have taken a charged rod. Okay, Anand Fiza, good afternoon. Malay, I have taken a charged rod. I have taken a point P randomly at a place. The point P is r distance away from the rod. And how we have taken the orientation of the point P? From the length of the rod, the point P is making angle alpha from this right side and angle beta on the left side. Now what I am doing, I am taking one element on the rod. Let's say I have taken this element. Okay, if I have taken this element, I have written electric field due to this element dE at point P. That we can write easily, k dq by r square. So that's what I have written. After writing that, I have taken components dE cos theta, and this component is dE sin theta. Now if I integrate dE sin theta, I will get net electric field in horizontal direction, Ex. If I integrate dE cos theta, I will get net electric field in y direction, that is dEy. So in that case, what we can say, once I have integrated dE sin theta, so integration is becoming k dq by r square plus y square into value of sin theta. What is that? Value of sin theta? Theta we have mentioned here, right? So sin theta will be perpendicular y by hypotenuse under root of r square plus y square. That's what we have written here. Okay, Malay? So this we are integrating. This expression we are integrating. This integration, integral sign must also be there. And this integration is going further. Instead of dq, we have replaced dq by lambda dy. So I am writing lambda dy here into y by r square plus y square raised to power 3 by 2. Now y dy upon r square plus y square raised to power 3 by 2, integration of this I have done by putting y is equals to r tan theta. And this is something we commonly do many times. So all of you will be able to find the PDF of today's class on eCareerPoint app, which is available on Google Play Store. So whatever we have discussed today and whatever we have covered here, whatever I have written on the slides, everything will be available in a PDF on eCareerPoint app. You try to figure out where the free content tab is. So once you open the eCareerPoint app, which you download from Google Play Store, on that app in the free content tab it will be given the PDF of this whole class will be given. So I suggest you people to actually revise whatever we have solved today and write it from your own hands, thinking step by step. Okay. So all the best. Take care. Enjoy your day. Bye bye.